Hello everyone, for first updates now, I'm Tyler Olds and you're watching Behind the Bot. It's a fun show where we dive deeper into FTC robots, what makes them work. And today I'm here with team number 16412 Triad Robotics coming in from Richland Hill, Texas. This team had a fantastic 171.83 OPR at their last event. Also at one of their qualifiers, second Inspire and first place Think, and they were actually a former FRC team, so we'll be going a little bit more into that. And today I am here with Austin, Justin, and Kwa, and we're going to be talking a little bit more about this robot, what goes into it, some of their iterations, and really all their successes they've been having all here on Behind the Bot.
Giving you a voice.
Making it loud our own way.
Welcome to the fun.
We would like to thank our friends at Stryker for supporting fun so we can continue to make content for you. Stryker makes some of the most revolutionary medical equipment and is a big supporter of FIRST and its participants. If you are looking for an internship or career that supports you being in FIRST, check out careers.stryker.com to learn more. If you're on an FRC or FTC team and you're currently meeting safely in person and have a functional robot, we'd love to have you on our Behind the Bots or Behind the Bumper segments. Go ahead and reach out to us on any of our social channels, on Discord, or send us an email at admin@firstupdatesnow.com, and let's get your team scheduled to be on First Updates Now. So Kwa, we're going to be starting out with the intake on this robot. So with many robots, love to hear about the journey that the ring takes through the robot. So tell me about some of the iterations that you've had, what successes you've had, and then a little bit more deeper dive into your intake mechanism.
So at the front of the robot, as you can see, we have the first ever intake. We use complaint wheel and surgical tubing in order to take in the ring. And after we take it in, we connect to the transmission, what we call transmission. We're using two belts we add some grip tape onto it to make it more gripping, easier to transmit from the front intake into the indexer. And it's actually connect together with using the chains. Right, as you can see right there, it's connected with a chain, and we run it on a 5-to-1 ultraplanetary motors. So it gives us less intake time. So less time to take in all three rings, while give us more time to do more cycle during the game.
So let's see a ring go through on here. I'd love to see intake on that. And Kwa, if you don't mind just asking, with belts that big as well too, have you had any issues with like belts slipping or falling off or anything like that at all?
Well, yes. First of all, it's sometimes easier to get the belt off the gears. So it's not really a big deal, but like it's happened most of the time. But luckily we got that fixed now by tightening it up as hard as we can. Also with the front intake right here, because of like it's feeling up and down, so it's really hard for us to take in a stack of ring. So we're trying to improve that while we still in the middle planning to make it adding a blocker to help us improve in taking in a stack of ring easier by just taking one at a time.
Sure, and let's see the robot actually intaking a ring or two there, and then we'll follow up a little bit more. Oh, so something I didn't notice on your intake there is how when you were hitting against the wall, the intake was actually kind of flexing upwards a little bit. Can you talk about that design a little bit?
It's all because of the complaint wheel that we apply to the intake that actually grip onto the wall. Also, the front of the intake is really easy to move up and down because we add some bearings to make it flexible. So that's the reason why it's kind of go up when you go against the wall.
Yeah, no, I actually love just having the bearings on there, and those are just free spinning, right? There's nothing resistant against them, right?
Yes.
Really cool. So let's continue moving on as that goes into your hopper. We'll be going into the shooter then, and Austin's going to be covering a bit more about your shooter, the capabilities of it. And then Austin, love to hear a little bit more about your magazine as well, too, that you hold it in.
All right. So I'll start off with our hopper. So our hopper here it's just a simple CAD design. It's basically just a little bigger than the rings and allows us to use this actuator to hit the rings into these two wheels. Our flywheel is on a 1-to-1 Rev Ultraplanetary. This is just so we can have maximum RPMs. I believe it's around 5,000 RPM at the current state. And we also have this Rev dead wheel that we use. This just allows it to grip on, and it just adds compression, and it also spins like a frisbee to just add for consistency.
So we've seen a lot of teams doing that, the one dead wheel with the power down there. So when you're looking at that ring actually coming through, and we'll see it shooting just a little bit on there, how did you gauge how much compression to use between the side of the dead wheel versus the actual active wheel that's actually spinning?
We used many different wheels. We used a Rev grip wheel and a couple different sizes of the Go Build a grip wheels, and just found the standard Rev grip wheel that you get just normally in kits was just the best for the compression. Usually for the Go Build a grip wheels, it was a little too much compression for us. It added to the inconsistencies.
Yeah, fair enough in there. And then I don't know if I missed this. Do you have a servo that just pushes the rings out of your magazine, or how does that work?
Yes, it's a small actuator in the back. We have positioned it to where it is basically almost touching the rings, and we have it to where once it actually actuates, it goes the minimum distance it has to, so we can get the rings out of there as quick as possible.
Yeah, can we see a couple of these shoot out? And I'd love to keep the camera focused on the shooter itself so we can actually see them being pushed out and shot out. That was like butter. I didn't even know it was shooting at first.
Yeah.
No, wow, that was really cool. I think that was less than 3 seconds, to be honest with you. That seemed very very fluent. I know maybe you weren't waiting for it to rev back up, but it just seemed like a very fluent transfer through all that. So nicely done on that. And then next we're going to be going over to Justin, who's going to be talking about your wobble goal mechanism, the claw that you use for it, and we'll see how that picks it up as well too, Justin.
All right, thank you. So this wobble goal claw that we have right here, we actually use a ultraplanetary motor that's I think 5-to-1 or 10-to-1 ratio, and we also use a gear ratio for even more torque power to pick up the goal. This is actually a new design that we have, and we decided to make it a lot wider so we have a lot more leeway to actually pick up the wobble goals, and decided to have just a standard extrusion and extrusion going down for maximum surface area to grab it onto. And we also have right here, this also stops the wobble goal from going too far into the actual belt system.
That might honestly be one of the beefiest mechanisms I've seen for the wobble goal so far on there. Yeah. But I like how much leeway you have in regards to getting the wobble goal itself. So before you had that, what did you actually use prior?
Prior, we actually had a much smaller design by choice. But as the more and more we thought about it, the more less it worked. Or that makes sense. But so the more time we used it, we figured out that if we actually we can just have a single extrusion actually grabbing onto it rather than a more complicated system. And we found this a lot simpler and easier to use other than our other one, which honestly was a bit slower and it was slipped a lot more.
Once again, 16412 Triad Robotics coming out of Texas. Thank you so much for taking the time to talk to us about your robot. Looks like you have a fantastic machine. It's been performing great at your remote events, so we can't wait to see, with regionals and hopefully state coming up for you too, how that performs. Thanks for taking the time.
Yes, thank you.
We would like to thank our friends at Stryker for supporting this video. Stryker is looking for current and future FIRST alumni to join their internship program and FIRST mentors who are looking for a great career with a company who actually supports their FIRST journey. Go to careers.stryker.com to learn more. You can also directly support Fun by joining Fun Nation. Click the join button, and just for a few bucks a month, you'll unlock special perks and directly support us so we can keep making great content. Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow. And check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter.